Hello and welcome to a new episode of Deep Dive into Applied Sciences. My name is Martin Seng, I'm your host, and today I have a very special guest, and this guest can introduce himself.
Thank you very much. My name is Nikolai Hepke, and I'm a PhD student at the Hochschule Trier for about now a bit longer than 3 years in computer sciences. And I've already did my master's and bachelor's degree here at the university in medical informatics.
Thanks for your introduction, and you have a very, special topic overall for your PhD, and this topic is back pain. Well, not only back pain, but before we dive deeper, please describe your project in one sentence, if possible.
If possible, one sentence. That could be hard. So we are trying to combat back pain using virtual reality techniques or extended reality techniques. So we try to develop a low-cost home solution in which you can use a digital physiotherapist to combat your back pain instead of using a real one or assisting to a real one. So you got a VR or XR headset and get a digital therapist, and he or she will tell you how to do your exercises so that your back pain gets better. This was more than one sentence.
No problem, I will allow it. Well, for someone like me, can you explain the differences between something like VR and XR? Because you mentioned both terms and I don't really know what they mean.
So XR is the header term for VR, mixed reality, MR, augmented reality, AR, which XR can describe each of them. So, and VR is the headset most people know. So you take on a headset and you are in a completely different environment. Everything you see is digital. And AR, on the other hand of the spectrum, is where you see your normal reality, like an AR glasses. You can see everything around you. Like if I had one, I could see you. But the reality is augmented by digital objects. So I see you and maybe like a virtual cup of coffee here, for example. Then there's mixed reality in the middle, which means there are multiple different definitions for each of these terms. But mixed reality is often referred to augmented reality, which is spatially registered. So I get a digital coffee mug and I place it digitally on the table. Then I could move around the table and the object would behave like a normal object would. So if I move around it, I would see the other side if I stood on your part. And this mixed reality is what we use in our project right now. So you see everything around you, including a digital physiotherapist who would stand in the room and could talk to you.
This actually sounds very complex to me. But now that we've established some ground rules, what is what, the overall topic or the name of your project is Development of an Immersive XR Biofeedback System for Movement Therapy in Back Pain Patients.
This would
very
be
long title.
a better one-sentence description than the one I did before. Yeah.
Well, before someone told me, it's virtual reality against back pain or XR against back pain. Maybe that's the headline of the episode. But you are not working alone. You're working with various departments. You're working with psychology, with computer science, and also with therapy science. What are the challenges of your, interdisciplinary approach?
Well, the disciplines work quite differently. So that starts with the way you publish something, the way which data is important. There are some clashes. If we do a paper together, then especially with a psychology students, PhD student, then we on our informatic perspective, we think, oh, you have to include everything, like the data, the method, the code you used to process it, and then so the people who read the paper can actually recalculate it. But this is highly unusual in psychology publications. So we are like, oh, there's missing a big part, and they're like, oh, what are you talking about? Then we have to find in the other way around. We in the informatics department, we do some things that are really weird for the others. So for each publication, we have to kind of work around or keep in mind the way the others publish and work. And especially in the work environment, so when we develop this system together, there are some problems that it's for non-IT people usually really hard to estimate the amount of work any certain task takes. So if you get, for example, the XR physiotherapist, and you tell me there should be an avatar, like a digital human, and he should stand on the ground. And then you're probably thinking, oh my God, this is so much work. He has to get the avatar, he has to get the registration right and everything, so on. But for me, this could be as simple as downloading an avatar, placing it on the scene, and then the glasses do the rest for some simple scenes. But other things, like if you want a certain way of grabbing something, or you want to include a change, that can be really hard, although you hardly see any difference in the finished product. Because in informatics, it's really important you establish what you need in your project as soon as possible. So your project needs to be able to do this and this and this and this, and then you build up on those. And then if you include another one in the end, and you say like, it would be cool if it has multiplayer, for example. Like, I get the glasses, I see the digital physiotherapist, and then you get one as well, and we could do it together. This would be really hard, because then I'd have to do a network communication for each and every step along the way, and I had to rearrange the entire architecture. But for you, or for the end user who might not work in IT, they would think, okay, I get one glasses, you get another one, we can place it at the same position. Why doesn't it work? Why is it that hard? So we often get problems where where it's hard to estimate it, and where, for me, it's hard. For me, where I really had to learn to communicate. This is hard. This is much to do, and this is maybe easy. So we started out and had some problems where the colleague was like, "Oh, I wanted to ask him for this change, but I think it's too hard. So I don't ask." And then later I found, oh, okay, what he wanted was to add some big digital object. But it really doesn't matter how big this object is. I mean, I can include it in there. So it was a change of like 30 seconds. So we had to find a way to groove in to just say aloud everything that we want to include. Then I have to really think about it, how much work would that be? And then we can together decide what has priority and what could be
So
left.
even though you have very different ways of working, you still work together as a team throughout the whole project.
Yes and no. Actually, I work together with the physiotherapist as well as the psychotherapist, psychology student. So we work together with both, but we really early on saw that that what we need from each part is quite distinct. So there is like a physiological and a psychological component to back pain, and it's really hard to do psychotherapy while you're doing squats. So we kind of split it a little, and then in the end we bound it back together. So yeah, I worked together with both, and then we had some work as a group But it's hard to include all three because it could be quite different.
Let us stay with the back pain for a moment, because we all know what back pain is. We all know people who suffer from it. I know a lot of people that work out a lot. They still have back pain. I know people that don't work out at all. They still have back pain. So why is back pain such a common phenomenon in our society?
There are basically two different types of back pain we can distinguish between. So we have like specific, like we're just talking about chronic back pain, not just back pain. Everyone can sleep a little bit, then you have back pain for a day, then it's fine. So we don't care about that. But we're talking about chronic back pain, and there's specific chronic back pain, which has a specific cause. Like if you have a cancer in the spine, if you just had a surgeon working on your spine and an operation on the spine, then you have a back pain, and then you have a reason, and then you combat the reason, and your back pain usually goes away. What most people suffer from is unspecific chronic back pain. This is where you don't know the reason, and these reasons can be very diverse. So it could be that you overexert yourself, like your friend who does too much sports. Then your back pain is overexerted, and your back is overexerted, the muscles are maybe moved a little wrong, and then they start to hurt. Then you got weak muscles from people who do too little sports. They have weak muscles, they can't really hold up the back really that good, and this can cause back pain. Then you have people who have bad posture, like we all know if we're sitting on the table and then we're sitting like this.
That's basically me. That's me.
Then we do also start to have back pain. But there are also psychological reasons for back pain, like depression, anxiety, and stress. Especially stress is what people usually have as a reason they cite for back pain.
So how does your project specifically intend to tackle back pain or to combat back pain?
So we have two main pillars, like I hinted on before, the work I do with a physiotherapist and the psychology work we do. Like the first pillar, the physiotherapy, is we try to explain to the patients which exercises they should perform, like a squat, for example. Then they get the glasses and they see a digital physiotherapist telling them, this is the squat, this is good for these and these muscles, you should do it like this, you should take special attention to some of these movements. And then we track the person while they do the exercise. So we have little 3D cameras. We use them to scan, for example, you do the squat, and then we get a rough estimation of your pose, like all of your joints and how they are set up to one another. And then we can compare this to a good example of a squat, and we can tell you, oh, you're maybe going too low, or maybe you separate your knees too far to the outside, or you take your knees too low together, or you don't come up as high as you should, or your back is maybe round instead of straight. And then the digital physiotherapist can tell you exactly what's wrong with you. Like you get different scales where you see the process you do during the exercises, and then they could also talk to you and say, okay, please keep your back straight, like a normal physiotherapist would as well. If you perform a squat in front of a normal physiotherapist, he would or she would tell you to straighten your back if you do it with a curved back. And the other pillar is the psychotherapy. So, as I said before, back pain can be caused by stress, anxiety, depression. And for people to know that this can be a cause or a reason or a contributor to the back pain, this is usually really helpful. So if you normally combat lower back pain, you usually get something that's called psychoeducation, where you understand the mechanics involved, like the psychological and the physiological and the social, that can cause your back pain. And we have one we call it scene now, where you get a digital physiotherapist, and they will talk to you about the reasons that could be caused by back pain. And you will explain it to you, and then you have to do some tasks, like understanding where it comes from, thinking about the biopsychosocial model, building it up in 3D. So you have to grab something, move it, and then fill out tables in that manner. And that way you can learn about your about the reasons that cause your back pain more effectively. And we also have a relaxing exercise in it. So it's confusingly also called body scan, where we use cameras to scan the body, but this is where you scan your body from within. So you feel your body. It's like a guided meditation, which is helps to relieve stress. And then you get like a relaxing environment around you, and some things floating around, and yes.
Let's take us one step back to the digital therapist. You mentioned the therapist quite a few times. How does it work? What I mean exactly, if I'm doing like 10 squats and all of them are wrong, does the therapist recognize that I'm doing the wrong technique? Does the therapist recognize patterns? Is it like an algorithm? How does it exactly work?
So, as I mentioned earlier, we have these little cameras that are called Azure Kinect. So maybe some people know the Kinect from the game controller. Before there was the Xbox Kinect, which would track your body while you move, and then you had to play a game like this. And we're using a more advanced version of that. So we know how you move right now, for example. Like we can track your entire body, and then we can find certain distinguishing points that are relevant for the exercise. We can model an exercise as a sum of different constraints. For example, if you're doing a squat, then you need to bend your knees from 0 degrees, like standing up, to maybe 90 degrees, like slowly bend down. And then you can model it for each application. If you're doing some really tough squats, maybe you want more than 90 degrees, but usually the therapist has something in mind. So you shouldn't, the idea is that you shouldn't go over 90 degrees, for example. Then, as I mentioned earlier, maybe you need your back is curved or straight. This the exercise requires you to keep the back straight, but not upright, just like not curved. Then you need to point your knees. If you're doing a squat, if you point your knees too far outward, you could maybe hurt yourself. If you do it too far inside, you are not stable enough, and you could also hurt your knees. So this is something that we can focus on. So we have these different constraints, and we know, because we have the skeleton data, if you break one, for example, if your back is curved, we know some points along your spine. We can see if they are more or less on a line. If they deviate from that line, we know it's curved, so we can say something. Obviously not if it's just for one frame, then we see here might be a problem. And then we have some constraints that are always active, like your back always has to be upright, and your knees should point in the same direction, so you don't move the way your knees point in any way during the squat. But then we have active constraints, like the bending of the knees. So we can follow how many degrees do you currently have? Are you at 0 degrees? Are you at 90? Are you somewhere in between? And then we can determine where are you within the exercise. So at the very beginning, at the very end, maybe you overexert yourself, you go too deep, then we can give you a warning. And then or you don't go high enough, then we can give you a warning. And if you are anywhere in between and moving, it's a little more complicated than that. But then we can say, this is all right. Then we can count how many you do. And we've quite early found out that it's really annoying if the person would just talk to you. Because if you have a real person, it's rather easy. They can go up to you and say, you move your knees point into the wrong directions. And then they go to you and show you where you should do that. This is really hard in mixed reality. Therefore, and if they just talk to you or do it more outwards, please complete the exercise correctly, then this could be really confusing to the users. So you also have different scales. So you have a big scale that tells you where you are in the exercise, so you know when you're right before the end of the 90 degree, and then you can go up again. That's all right. And we also have for the direction of the knee another scale that lies flat on the ground, so you can actually see, oh, am I in the green? Like, is it pointing to the right direction, or is it too much inwards, too much outwards? And then the therapist would still talk to you and still say, okay, you're doing this wrong, but only to point you towards the scales where you can actually know what you're doing wrong. Right now.
So I'm playing devil's advocate here.
Okay.
I could also go just to a real life physician.
Of course you could. Yes.
So why should I take the HoloGlass or the HoloLens, put it on my head and do the exercise at home? Am I the wrong target audience maybe?
No. You could, in the perfect world, you wouldn't need that. Then you had enough physiotherapists where you go 3 times a week, and then you exercise together with them, and they tell you exactly with all their expertise what you're doing wrong, and they would probably, so I know they would do it better because they are trained in that way, and they have no measurement errors. They know if you're doing something slightly wrong, they could still improve you. But we don't live in that world. We have a shortage of physiotherapists. So each physiotherapy relies on you doing your exercises at home. And so you go once a week there, and then you will get homework, and you have to do your homework for the therapy to work properly. The deal with that is that many people are afraid to perform the exercises on their own. They think, maybe not your friend who does too much sports. They would probably do it fine, but the one who does too little sports, they would think, if I do my squat, the muscles start to hurt. I don't know if it's the muscles or the joints, so I'm afraid if I am doing it right now wrong, I could hurt myself and worsen my condition than if I do nothing. So they do nothing instead, which is actually worse than doing it slightly wrong. And for those people, we try to give guidance. So for one, they are not alone. They are, we check if they do it wrong or if they do it right. Then we show them the exercises again. So they don't get just a piece of paper where it says, okay, this is a squat, maybe 1 picture or 2. They see the entire exercise in 3D. And then they can do it at home alone and still get the feeling that they're being watched. And they can actually show those recordings, like the recorded positions of their joints, to their physiotherapist and tell them, am I doing it right, if they don't trust the system. And then they could replay the scene and say, okay, that's all right. Or you seem to have problems with these exercises. You can't really work them out alone. Maybe we give you another exercise. So it shouldn't replace any real physiotherapists, and there's really no need to replace them because we already get too little. But we can augment their work with augmented reality. Like we could help them to do the real hard parts, like the anamnese, where they talk to you what is hurting, where they decide which exercises you should perform, to which extent, how often, and then the actual performing of the exercise. This is something that we can automate, where the valuable time of the physiotherapist is probably better used somewhere else.
For all these exercises, or for your whole project in general, you are using the mixed reality glasses HoloLens. Please correct me if I'm wrong.
HoloLens 2 actually, but yes.
HoloLens 2. And you also use a lot of sensors. You already mentioned Kinect. There's a lot of technology and programming involved. How expensive is it overall? Because for me, this sounds very expensive because of all the technologies and so on.
Yeah, it's quite expensive right now. So you have like the HoloLens, it's 3,500 euros. So small car that is used. Then you get the Azure Kinects that are 400 euros a piece. But each Kinect needs a PC to process the depth image it gets and to calculate the movement of the person that is currently filmed using machine learning techniques. So we need like probably 800 euros as well for each Kinect. And then we need one PC that can run the rendering of the HoloLens. This is like another 1,000 euros maybe. So we stack up quite a bill to perform this.
So we are roughly in the range of 8,000 euros.
Yes, maybe, yes. But the idea is that we are not using this work is just for today's usage, but with the future in mind. So right now you get VR headsets like the Quest 3 that also has a see-through AR mode, where you have cameras in the front of your VR headset, and then you see your environment similar to reality. And then you can still use an application that was built for the HoloLens for 3,500 euros, but on this Quest for just 500 euros maybe. This also has a more powerful processing unit, so you probably could do without the rendering PC. So you cut 5,000 of the budget, probably. And by using different technologies. Then we currently use three Azure Kinect systems, which are, like I said, together maybe 1,200 euros. But the pose estimation technology is improving quite rapidly. So in a few years, you could probably do that with less systems and with less powerful systems or less demanding systems. Modern, like there are motion capturing, motion estimation systems that work on your smartphone. So you could use, in a hypothetical scenario, you could use the LiDAR of your iPhone to process your position in 3D in real time, send it to a rather cheap VR headset, which might be more available in homes in the future, because we saw in recent years that people bought even more VR headsets than, so they are more available in normal households for gaming or sometimes productivity, but I don't really believe it. So if somebody has already a powerful smartphone and a gaming VR headset, they could do this or run a similar application cheaper. So maybe for nothing, but just the cost of the software. And for the state we are right now, these motion tracking systems that run on your smartphones are not accurate enough for what we demand right now. So we can't do this at the moment. But the idea we have in mind is that you could set up this system in a physiotherapist praxis, and then you go on Monday to your real physiotherapist, and on Wednesday and Friday to your digital therapist. And there you could book a session as well. And then the real physiotherapist could integrate those systems in his praxis, where he says, oh, I saw you've been training. I saw you've been training really good. So I know your progress. They could show you how much you improved over the time and motivate you like this, and can say, okay, we see this works great for you. Maybe we dial down the support, and the digital physiotherapist would not show so many scales and would maybe talk less to you, up to a point where they don't talk to you at all, and where they know you can perform the exercise on your own without the supervision.
So this is basically your idea how to transfer your project, or let's say the data of your project, into the industry. That you work together with different doctors, with different physiotherapists and so on.
I mean, this is an application, a scenario that we are thinking about, but the actual implementation is not part of the project, actually.
So your research now basically helps people in the future.
Yes, that is the core idea. I mean, most research topics are set up that way. You find a problem, you work on that problem, and someone else picks up at some point where you left off, maybe introduces a new idea we never had, and then builds it in a different way, and builds up on it, and then somebody else will build up on it, and then somebody else will use it, will refine it, maybe turn it into a product, and then introduce to home users or like a physiotherapist practice.
Since when do you work on the whole project?
I've been working on this since for 3 years now, and yes, with my colleagues.
And when exactly do you plan on finishing? I don't expect an exact deadline.
We are at a point where we finished most of the software solutions already. It's like we now just did a study about different aspects of the biofeedback, where we could define which helps really well and which does not work. So we're currently at working on the results of the study. So I can't talk too much right now, but the software is really in a really good state, actually, where you could, with some polishing, implement it in prototyping praxis, for example.
And if you look back at the last 3 years, which were the hardest obstacles you faced, and how did you resolve them?
The hardest obstacle was actually finding out, like quantifying the accuracy of the Kinect cameras. The idea is usually you have a system, any system, which you want to compare for its accuracy. So you compare it to the gold standard. Like for us, it's like we have a home system, the Kinect, which you can buy for 400 euros. We want to compare it to a Viken system, like a big motion tracking system they use for movies. Those are much more expensive, much more effort to set up, but highly accurate. So there's our gold standard. The problem was that our gold standard influenced the measurements of the Kinect. So whenever we simultaneously measure with our system, our Kinect, and this gold standard, we actually sharply decrease the accuracy of our Kinect measurements. So the problem was, how do we measure without impacting our system? There we had to build a whole other system. Maybe I could go into detail with that. And had to have a really big study, 20 people, each for 4 hours, performing these 10 exercises 3 times.
And all with back pain.
None with back pain, actually, because if we had anybody with back pain for 4 hours doing exercises, I think they would leave. And the ethics commissions would probably not be happy about that.
True.
As well. Now, if we want to find out the accuracy, we just use people who are athletic, and then we can work with them and maybe repeat some measurements over and over without overexerting them. So this is actually really important for that.
So to sum it all up, you are combating back pain with the development of a mixed reality lens, which directs people with the help of a digital therapist to do exercises against back pain in the right way.
Yes, for a mixed reality headset. I don't develop the headset, but yes.
Okay. Just to be precise. So this sounds very interesting. Maybe I should try it myself with my back pain, but hey, that's my personal issue. If people are interested in your whole project, and I guess there are some people, how can they contact you? And also maybe people from the industry and wherever they come from, how can they reach you?
So I plan on staying with the Hochschule Trier for a while. So there's my personal website at the Hochschule Trier with all my contact information. So just Google Nikolai Hepke, I guess, and maybe Hochschule Trier. I don't know how many others there are. And there you'd also find the publications we did. So our findings, and we update it when we publish the paper about the biofeedback. But there you can also find the paper on the system we developed for combating the interferences from the Vicon to the Kinect, and maybe some other information about the project. We also plan on publishing all the code and the introduction on how to build the system, so others can use it and build.
So others can use your code for future projects.
Yes.
So if you have any questions for Nikolai Hepke, if you have back pain yourself, feel free to contact if you're interested. And yeah, thank you very much for coming, for presenting your PhD project. It sounds very interesting. I will look out for it. And thanks for coming. And thanks for listening, maybe for watching. And until next time with Deep Dive into Applied Science.